So a little bit about me. My name's Callum. I'm a Microsoft MVP, and I work with a .NET-based CMS called Umbraco. Does anyone know of Umbraco? One person. Yes, it's made its way to Australia. I'm a .NET developer by trade, but I run a company in the UK called Bump Digital. I'm the chief bumpster. I speak at lots of events. In fact, I've spoken at an event every single week in a different country since January, which has been quite tiring. I organize my own events as well. Like a lot of white guys in tech, I have a weekly podcast for my sins. I do my own open source projects, of course. I have a passion for cooking, especially Italian food. Love Italian food. I love beer. Just love those kind of cultures in general. I travel a lot. Like I say, I've been everywhere so far this year already. Why am I telling you this? I'm not trying to brag. Where do I find the time? Well, of course, I have an army of clones. This is Callum A. Whyte. This is a kind of Dylan Beatty style knockoff, cowboy hat, black sunglasses, etc. There's Callum B. Whyte, which is the one that's on stage right now. You can find me on Twitter, LinkedIn, etc. at that handle. And there's Callum C. Whyte, who's got gold teeth and a chain and thug life hat and glasses. Of course, that's not quite true. We've all dreamt at one point or another that we could clone ourselves. Have that extra pair of hands, a clone that could do the dishes whilst they're out, or just get your work done a bit more efficiently. Now, during COVID, I saw a really funny video made by a guy called Jesse Orrell. He's a video producer for CNET. And he created a video where he virtually attended his meetings for a week. I don't know if anyone saw this. I'll make sure I share a link around after. He effectively recorded all of the things he could possibly need to say in his daily stand-up meetings and just had them on like a palette he could play when he needed. So he had some general longer footage that he could play to say, oh yeah, sitting there nodding along, sipping his coffee. Another one that just says, yep, no comments from me, sounds good, some thumbs up reactions. And then at the end of the week revealed to his colleagues, you've not actually been seeing me in any of these meetings at all. It's been pre-recorded versions of myself. He'd managed to scale his presence in meetings. I just loved that. I thought that was really fascinating. And around the same sort of time, I saw a great video from Donovan Brown, formerly of Microsoft. He's now retired, showcasing Azure's speech synthesizer service. And he'd recorded a video where he'd said, we've got a new service in Azure, and I can provide some samples of my voice, and it will generate a fairly realistic sounding version of my voice. And in actual fact, you've been listening to that so far. And I was mind blown because with seemingly relatively little effort, he'd made quite an uncanny copy of his voice. Of course, when I then heard it back again, I was able to pick up on little parts that, oh, okay, that did sound a bit robotic. But on first pass, it was very, very good. So putting these two ideas together, my question is, could I clone my own voice? Could I do what Donovan did? Could I try and do what Jesse did? Augment my presence in meetings? If it's just yep, all good, no updates from me, those daily stand-ups could become so much more fun, couldn't they? I just want to jump back to Jesse there a second. He's done something in a very low-tech way that actually resembles some of the key principles of training an AI model. He's come up with his key things that he needs it to do, key behaviors, and he created 2 or 3 variants of each of those. So each day he could give a different thumbs up or a different, okay, no updates from me type thing, because people would catch on pretty quickly if you were getting the same sort of stuff. But he then created snippets of video and audio and was using those in various different combinations. And this is effectively the same process we have to do to train an AI model well. We have to come up with lots of data. We have to make sure that data is firstly high quality as well. We're going to talk about quality in a minute. And then we have to actually train something on that. In this case, Jesse was just pressing the buttons himself. But imagine if we could make a computer do that. So can I clone my own voice? can I clone my voice? It would be great. But this is the idea we're going to try and look at today. So, of course, with AI technologies, these APIs, these services have become more and more accessible. And I think that's really what's made this so possible today. I spent my whole morning scrolling Twitter today looking at OpenAI's Sora, the video generation thing. Absolutely mind blown. And 2 days ago, I was with some people on the boat here talking about OpenAI and having memory APIs and how much more powerful that's become. And I feel like there's a good AI news story every other day at the moment. Microsoft for a long time has made these tools super accessible through Azure, as have a lot of other cloud providers. We can enter our card details and within a couple of minutes be calling an API that generates, text in another language, or for things like DALL-E, where we can, do image generation. It's really, really powerful. Azure, of course, has a new I don't think it's new anymore, is it? An OpenAI service. All of the APIs or a lot of the APIs and the models that OpenAI have built themselves are available locally hosted on Azure. So we can gain direct access to those if we wanted to. I've seen examples of this becoming more and more prolific, more widely used. One great one was someone used ChatGPT to negotiate a credit card refund with their bank. It's like, okay, we're actually starting to automate parts of our life. You have influencers now who are automating their presence in, social platforms using things like ChatGPT. It's really got quite crazy. Anyway, we want to clone our voice. How do we do that? Well, I'm sorry that it's a Friday, but I'm going to give you a bit of a history lesson. In fact, a biology lesson first. This is the human noise box. This is basically how a human makes noise. And we kind of need to understand how all of this works before we can have a really good understanding of how a computer can then make noise that sounds like a human making a noise. So there's some very graphic videos of how this actually works online. Someone has literally shoved a camera down their throat and you can see all of this working. I thought we'd keep our lunches today, but effectively air flows from the lungs up the windpipe and it goes through the voice box. This is this area here, let's say, in the middle there. The vocal cords, the voice box, the larynx, they vibrate. And effectively, that creates energy. And with that energy, we then use our mouths, our tongue, our teeth to shape how that energy is being output. And therefore, we control the sound and make words effectively. There's some keywords that we're going to need to understand here. The first one is sonority. Sonority is actually the amount of energy that is used when generating words, and each word might have a different sonority. You can think of the word, bread. It's quite a soft word, whereas if you think of the word stop, it's got potentially more energy to it. So each word has a different sonority. Hopefully we're familiar with the term vowels. Vowels and also consonants. These are characteristics of speech, but again, these are fundamentally quite different. Vowels have a longer and open sound that use more energy. Ooh, oh, ah. Hopefully you'll be saying that after this talk. Consonants are shorter, sharper sounds that use less energy and maybe are more controlled in the mouth. T, k, etc. Syllables, again, hopefully these are things that people are aware of, but they're groups of these sounds. And they have peaks and they have troughs in those, especially where, as far as energy is concerned, because they are combinations of vowels and consonants. It's called the nucleus of a syllable, the kind of root letter, typically has the most energy. So if you think of cat, has generally got the most force behind it. And then finally, this concept of a phoneme. So a phoneme is effectively an attribute that makes a word unique. So this is the differentiator that makes, say, can versus man a different word. It's the C versus the M at the start. Ball, tall. They're actually the same words with very similar energy used to create them. So yeah, these are the differentiating factors. There's also, of course, other acoustic elements to speech. Sibilants, like a s sound that you'll hear quite a lot, especially in a room like this with microphones. It gets picked up. All of these things contribute to speech and human speech. And somehow a computer has to replicate all of this. How do we do that? I'm a big fan of Apple. I know it's not necessarily the done thing, but back in 1984, when Steve Jobs unveiled the Macintosh, has anyone seen the movie, the Steve Jobs movie? Where there's a famous line where he says, the computer has to say hello. It must say hello. So how do we make a computer talk? We have, nowadays, talking computers everywhere. You have them in your pockets. You have an iPhone or an Android device that has Siri or Google Assistant, or maybe you've got Alexa in your home. This isn't really a new phenomenon anymore. But back in 1984, when Steve Jobs unveiled the Macintosh, this was a huge deal. And let's have a little listen to what that sounded like at the time.
Hello, I am Macintosh. It sure is great to get out of that bed.
There we go. It makes jokes. So this is a fairly robotic sounding voice. It doesn't sound humanoid at all, in fact. An early example of synthetic speech being generated by a computer. In this case, this was being done on the device as well, so it's quite impressive. But the sound you're actually hearing there is a more early example of something that is very commonplace now in all speech synthesis. Does anybody know what this is? Said there'd be a bit of history in here, sorry. Okay, so this is a vocoder. And this might be a term that you're familiar with, or it might not. But I'll show you some examples. You'll have definitely heard one. A vocoder, it's a shortened abbreviation of the words voice encoder. It was invented at the Bell Laboratories, which became AT&T in the US, in 1938 by Homer Dudley. This was effectively used for scrambling communications during the war, during World War II. But it's really designed to synthesize speech. This kind of Frankenstein-esque keyboard would be played to generate messages. What it does is it takes an electrical signal through each of these keys. And when each one is pressed, it's going to generate a slightly different signal. It goes through a different set of filters, and effectively you're generating noise that will somehow sound a bit like speech. This, of course, was very early technology. We don't have vocoders quite in the same sense now, but it became very popular in pop culture even, in the 60s and 70s. It was started to be used in musical synthesizers like this Korg vocoder here, where you could plug in a microphone to a synthesizer, a keyboard, and put your own energy into that microphone and use the keys to effectively mutate, filter those signals. And then by the 1980s, you'll probably be, I hope, familiar with this. No? I have to click the button. I'm sorry. Amateur hour. There we go. So, this song is Earth, Wind & Fire's Let's Groove. I'll stop that because that's going to get really annoying. Yeah, that is a song that's using it. So actually this technology has evolved from being used for scrambling government communications in the war to effectively using it to generate a kind of robotic style voice for art, for entertainment. And there's plenty of other examples of that. Anyone that's a fan of Daft Punk or those sorts of people are using this to this very day. Nowadays, this same technology is working. We take in an electrical signal, we mutate it, modify it, and make it make the sounds we want it to. And that's how modern speech synthesis also works. Your mobile phone, the bus you got here today, the train you got here today, the announcements on those buses or trains, all generated by a software vocoder. When you talk to an AI assistant, it is a software vocoder that's actually doing that voice generation. Okay, let's quickly talk about AI, ML models, and how we train those. So a model's effectively, in its most simple form, a way of recognizing patterns. And so those patterns, these models are created with the purpose of being fine-tuned towards identifying certain patterns in data. Excuse me. So the models, they use algorithms to effectively best match data that's given to them to what they already know and validate that data, find those patterns. And if a strong pattern is found, you can effectively apply that existing knowledge apply the new knowledge to the existing knowledge and build up more and more confidence about certain bits of data. Training effectively just enhances the quality of your model. So, like I said at the start, Jesse Orrell, with his fantastic array of pre-recorded voice samples, he recorded 3 of each. But if he'd gone and recorded 300 of each, he'd have so much more variety, so much more accuracy, potentially, for each possible scenario, that effectively he's trained a model. So you could imagine this training being on a linear scale from 0 to 1, and I give it a piece of information on a pre-trained set of data, and it says, yep, okay, statistically, that is somewhere between what I know or what I don't know and what I know. So it's like a score of 0.5, which is great. But the more data you chuck at this, then we start to get a bit more variance, and you can see, okay, we fairly confidently know that something is matching what we're looking for when we have more data. So here, the real key is more and more data actually allows us to create models that are more accurate and arguably more efficient, because if you've got more data, there's kind of less variance to match against, I guess. So yeah, this is what we're looking at today. How can we train a model to be accurate and do this? Recent evolution of AI models has really come down to the way we do training. A lot of the algorithms, or many of the kind of core principles, at least, of AI have existed for a long time. But the modern ways of training these models and the modern ways of actually, highly powerful compute, etc., has made it much easier for us to create more powerful models. There's 2 ways of training 2 ways of learning, training a model effectively. You have isolated learning, which is where you take a data set, you give it a task, and then you effectively validate the result of that task. And you do that many, many, many times. And what it means is you can effectively confirm that your model matches a set of requirements, and then you move on. Where these more powerful models have become where models have become more powerful in recent years is through this concept of transfer learning. Effectively, the result of the previous task is passed back on to the next task. So as you give it more and more data, it's working off the existing knowledge that it already has from all the tasks it's completed before. And therefore, we can build up this really powerful, big bank of knowledge. Transfer learning is effectively what's made things like natural language processing possible, and is what's underpinning things like ChatGPT nowadays. Anyway, that's enough of the history lesson. We know that we need energy, we need data, we can effectively augment someone's voice. We also need a high-quality model with lots of training data in it to create a high-quality synthetic voice. Now, we're going to have a look at Azure Custom Voice today. This is a speech synthesis as a service. It allows you to train your own model, but on the basis of their existing models. So they've done all the hard work of training what a neural model might look like to generate a voice, but you can customize it. So we can bring our own voice to that and make it sound just like us. They have a Lite and a Pro plan. There is no difference in pricing here, which is really weird. You typically think of, oh, right, okay, so yeah, Lite means cheap and Pro means expensive. No, spoiler, they're all expensive. We'll go into the pricing a bit later. But there's a really important distinction there as well, which we'll touch on. How does this work? So the goal is to generate speech from text. We give it some text, and I want it to sound like me. Make some audio that sounds like me. It takes text input. It runs that through a text analyzer. And what that's going to do is pull out all of those characteristics that we mentioned at the start of speech, vowels, consonants, the sonority of different aspects of those words, so that it can give instructions to our neural vocoder to generate the right amounts of energy and the right sounds to make what hopefully sounds a bit like a voice that we are familiar with. From the training side, as I mentioned, Microsoft has done a great deal of work to create some base models that work for a lot of use cases. They've taken about 3,000 hours of multilingual, multi-speech content. They've ran that through training, extensive training of various different models, and then we can effectively fine-tune those ourselves. We can bring in our, they call it here, target speaker data, our training data, and then run it through the same process. So we just fine-tune that model. It uses something called fast speech, which actually came out of Google, to make that as efficient as it possibly could be. And then we end up with a model at the other side, which hopefully we can use. So I wanted to talk about responsible use. We don't want Troy Hunt standing on this stage in 2 years' time doing a talk about people's voices being pwned or whatever else. In fact, I've seen it all over social media, if we're realistic. The other day, Selena Gomez was selling me cooking pans on Twitter. I don't think she knows anything about this, but it's a genuine problem. People's voices will be stolen. People's likenesses will be stolen and used to promote things that are nothing to do with them. So we really want to avoid this. And Microsoft want to as well. They want to promote really responsible use with their products. Now, this is why they have that Lite and Pro tier distinction. The Lite tier is restricted to being certain phrases. It's effectively for testing. And the Pro tier is more, you need to use it for a very specific approved use case. You have to actually apply to Microsoft and explain exactly what you're going to do with that model that you've trained. So if you're going to use it for an internal purpose, you have to give them a lot of detail about why. And they regularly review this. So they're trying to keep a crackdown on, how and where you can use their the results of their service. The other quite powerful thing, which you wouldn't get with, say, an open source tool, is every voice must provide a talent statement in order to be used. So they expire after 90 days if you've not effectively given your consent to store the voice. It means I couldn't rip somebody's voice off the internet and just generate a voice, a neural voice with Microsoft service. I have to have actually had that person speak certain words, and that would be effectively them giving consent. Okay, we can dive into some actual training here. How do you train the Custom Neural Voice Lite model? Well, so these give moderate quality results. This is what Microsoft says. However, my experience is these are pretty damn good. And only getting better. I trained a model on this about a year ago and retrained one a few weeks ago, and it was completely, night and day. So they're pretty good. This allows you to, this allows you to record 20 to 50 specific utterances, phrases, or sentences that you could then use to train this model. And it's completely self-serve. So you don't need to hire an expensive recording studio with perfect conditions to record your voice. It takes about 1.5 hours to train, approximately 15 to 30 minutes to record these 20 to 50 utterances, and then about 1.5 hours to train. You can just sit there, hit run, and watch your Azure credits burn whilst you do that. And then when you want to use it, you have to deploy this model, and you can then use it with Azure's custom text-to-speech services. Their recommendations for having a good quality output with this are use a good microphone, avoid background noise, relax, make sure you're speaking naturally, maybe in the tone that you're looking for, record them in one take. And this is probably related to the previous point. If you have vast differences in the quality of what you're recording, you'll get a very different output. They give you some guidance to say, yep, that was good, that matches what we're expecting, or no, that's not quite right. And then the more samples, the better. If you can record all 50, it'll give you a much better sounding model. Let's have a look at it. Cool. So many people won't know about this, but you can go to speech.microsoft.com. This is Microsoft's speech studio. They have a studio for every AI product, it seems now. Azure AI Speech Studio gives you the power to do, well, everything. Speech to text, text to speech, and a couple of voice assistant things as well. I will show you a quick example of, let's start a new project, why not? So I can go down here to custom speech, start a project. That's not what I wanted to do, sorry. I can, is that what I wanted to do? Yes. Amazing. Create a project? No, I'll just go to my existing ones. It's fine. No panic. Yeah, tell me about it. Right, cool. So what it does is it gives you a really nice interface where effectively it guides you through the process of training your model. It gives you the 20 to 50 utterances that you need, and you have to record yourself saying these to your computer. It's rather embarrassing. And they make you say certain things that it just doesn't really feel right. What's this one here? So,
it's hard to deny that tomatoes are the ideal summer food.
It made me say that, and 50 other things as well. As I say, rather embarrassing. But effectively, it indicates how good the recording quality was. It will tell me if I've mispronounced a word or said something wrong, and then it will, I realized I clicked on the wrong thing, so we can go back and do this now instead. There we go. Let me choose if I want light or pro. We're going to just go with light for this. We can give it a name. I'm just going to call this NDC Sydney. Don't need to give it a description. Importantly, it makes me choose the gender, a bit controversial, and the language of the training data I'm going to be using. That's effectively because they're pairing that against a pre-trained model that's been classified in the same way. So I'm from the UK, so I would select English United Kingdom. I agree and click continue. Pretty much instantly available for me in the portal. I can go to the project. And like I said, it guides you through the process. Click get started. It brings up, whatever. What do I have to click? Oh, no. Accept. Amazing. Right. No one speak. So let's just try that again. Doesn't matter. Fine. This is purely really to guide on quality. And I click, got it, and then it guides me through the process. So here, would you like a cup of tea? Very British. Would you like a cup of tea? So it's telling me here that my speech was quite clear, my pronunciation was spot on, but I was too loud, and therefore I should probably re-record it. If I also try something like, would you like a cup of coffee? It's now realized that I've said the wrong word there, and it will again say I've mispronounced or excluded a word. So it really guides you through creating the best matched set of utterances for the model. Anyway, that was a bit of a tangent. What you end up with is a trained model that after you've done all of the utterances, you can submit and allow that to be used in your applications. Like I said, takes about an hour. Took here 1.04 hours to train my set of data. And when you go into here, you can then see all of the different pre-approved phrases that this model will let me listen to. So here you go.
Congratulations. You have successfully created your synthetic voice with Custom Neural Voice Lite.
Okay, so it sounds a little bit robotic, but it does also sound like me, which is, I think, pretty cool. I spent 30 minutes recording some audio clips, and here we are. We've got a voice that we can use anywhere. We can click deploy, and this gets deployed. Deployed is kind of a strong word here. It just makes it available to use in the other Azure services, in your account, in your subscription. It's not public or anything like that. And yeah, there's plenty of these in here. I will say, I recorded this on a laptop microphone. I wasn't using anything fancy. I recorded it at my kitchen table, and I live right next to a busy road. So all of the things Microsoft said about here's what you need to do to get the best quality, I'm not so sure if they actually apply. It's pretty good. Don't be that worried about not having the right kit, I guess is the important thing. Literally anybody can train a model. I will also show you, I've got another example where I recorded the exact same demo, but with a monotone. And, well, I'll play the tomatoes example again, just so you can compare.
It's hard to deny that.
We don't need to listen to it all. But the effect that has on the model is very interesting. Different training data, of course, but gives it a really different output. So this is the congratulations sentence again.
Congratulations. You have successfully created your synthetic voice with Custom Neural Voice Lite.
Okay, it did make me sound a little bit happier than when I recorded the training data, but actually it does carry across to the model. So when you're training your model, you do have to think slightly about the tone that you want to give it. If you want it to be friendly and upbeat, make sure your training data is friendly and upbeat. I know no one in this room is probably a professional actor, but you might just have to put a little bit of extra personality into some of the things you say. Equally, if you're going for a more corporate tone, that's fine. Just work out what your desired sound is, and make sure your training data covers that, because on the light version at least, it will just take what you give it. Let's just jump back there and jump back here. Okay, what about accents? For me, most people in this room have an accent. To you, I probably have an accent. This is perfectly normal, of course. Everywhere, all over the world, people have different accents. Is it such a thing that even within Australia, you can tell where people are from based on accent? Yeah, okay. It's the same in the UK, of course. There is a whole bunch of supported languages out of the box. This includes EN, UK, US, Australia, and Canada. They've got French, German, Italian, Japanese, Korean, Mandarin, Portuguese, but only for Brazil, and Spanish for Spain and Mexico. Now, The reason that they've got this smaller subset of languages is because the training data exists, ultimately. Brazil is a much, much larger country than, say, Portugal, much larger Portuguese-speaking user base, I guess. So they're able to get different training data for all of these people. If you don't fit in any of these categories, it doesn't matter too much. My experience is you could typically take the English US model and train it with pretty much any language, and it kind of comes across about right. But yeah, do consider this when you're deciding which base model to train your or to fine tune. My girlfriend's French. She's lived in the UK for 7-8 years now, and she has this weird hybrid accent. Still French, but speaks English. And so I thought it would be a bit of fun to see if we could get her to do one of these as well and just see what happened. Does it make her sound really French? Does it make her sound super English? What happens? So yeah, we did that. I have this Frenglish model here for fun. And she's gone through the exact same process. Just for your reference, here's the tomatoes one again.
It's hard to deny that tomatoes are the ideal summer fruit.
Okay, there's a few Frenchisms in there. De instead of the or z. It's a fairly stereotypical Frenchism. If we then look at the deployed model and have a listen to, that first one again.
Congratulations! You have successfully created your synthetic voice with Custom Neural Voice Lite.
So it's kept a lot of the characteristics of her voice. It has made her, if you listen to some of the other ones, a little bit more English sounding in some places because we selected an English and UK-based base model. But it, had a very interesting result. I had a try with this just in the hotel room over this week to do an Australian one and see what would happen there, because English Australia is a possible thing. And I'm disappointed. It just sounded like me. It didn't make me sound Australian, but in this case, it has tuned something. So you've just got to, maybe try a couple and decide what works best for you. But it is really important to make sure you select that base model correctly so that you can train or get the best potential output out of it. As well, whilst we're on this, the recordings that she did were much worse quality, but you'll notice that actually the output is nice and loud and very clear still. So it just shows that the model doesn't have to be trained with crystal perfect audio. Okay, we've talked about this Lite version. What's the difference between Lite and Pro? So the Pro is designed to have a much higher quality, much more natural sounding output. Now, I don't know about you, but the Lite ones sound more than good enough to me. If I was using that even in a professional setting for an internal app or even a customer app, I would feel fairly comfortable with the output there. But if you really wanted to invest some time, you could. You require 300 to 2,000 utterances instead of that 20 to 50. And you can use from different scripts that Microsoft have got there, or you could use your own. So in my case, I mentioned I have a podcast. I extracted my podcasts from the last 3 years and uploaded all of those. It was several gigs, several hundreds of hours of content. And it did go away, crunch and train on all of that. But was it any better than the 15 minutes I spent recording? Probably not, in honesty. I have a Polish co-host on my podcast. So sometimes the speaker recognition wouldn't get it quite right, and I'd end up with a weird Polish accent a little bit as well. So yeah, it's not all that would be what I say. What you can do here though is train different styles of voice, things like whispering, things like anger, things like a more serious or professional urgent tone that if you were going to use this in a call center actually might be valuable. So do consider that. I mentioned it allows you to upload big amounts of data. You can upload MP3 files. You can upload zips of MP3 files. You can also upload those alongside a transcript, or you can decide to let Azure transcribe these themselves. You can, with the transcript at least, indicate who the speaker is by saying, Callum Marchin in this case for my podcast. But if you don't, that's also fine. Their services will kind of fill in all the gaps. I can very quickly show you that, I think. When we go up to Custom Neural Voice, we create a project, we select Pro, we click Next. That's just NDC Sydney. Click, create, that's fine. Create here. Add a voice talent. Oh, is this going to make me fill in? Yeah, okay. I mentioned before, it makes you select the exact use case you're actually going to use this for, and then they follow up and check to make sure you are using it for this use case. So make you fill in a lot of paperwork. We'll skip this then. But you can effectively decide, or you can tell it, this is the data I've given you. It is just MP3 files. You go work everything out. Or no, there's some text files in there as well for transcriptions, etc. The training takes about 24 hours, and it depends on the volume of the data you've given it. Those sort of 300 utterance type things take about 24 hours. Those 2,000 utterances are going to take a hell of a lot longer, and it costs a lot to train. So bear that in mind too. They recommend a professional studio recording with a voice artist when you're using something like this. Like I say, you've really just got to decide what is worthwhile for your use case. So let's talk about accuracy. Now, as much as possible, you're able to dictate pronunciation, accent, etc., purely by the training data. But because these models are based off of thousands of hours of pre-recorded content that people of all over the world with lots of different pronunciations have provided, the model's not always going to get it right. So how can we tweak this? There are cases where you may have business-specific terminology, a brand name that has to be pronounced a certain way. Is it Nike? Is it Nike? Adidas, Adidas, very common ones. So to control this, we can actually use what they call an IPA file, International Phonetic Alphabet file, where we can define those phonemes to effectively determine how words are pronounced. There we go. Let's just jump out of here quickly and over to Speech Studio. So if we scroll down here, we can go into the audio content creation tool, which then gives us a way of, as I said, defining some key words. In this case, I've got a lexicon file for ENUS, which has a couple of words in it. These are just the simple out-of-the-box ones. BTW, by the way, hello, and it determines the pronunciation of those. In my case, I work with a product called Umbraco, and there is a famous video, famous within this very small community, famous video on YouTube of several people being asked, how do you pronounce Umbraco? And they go, well, obviously it's, and then 15 different pronunciations. It's very, it's from Denmark, so maybe you should be following the Danish pronunciation, but it's very popular in the UK, so maybe people follow the UK pronunciation. I don't know. Of course, if I'm training my model, I want it to sound like I want it to sound. I want to be able to control this. So what I can do is define in International Phonetic Alphabet syntax, I can define how this should be pronounced. So in this case, it's something a bit like that, which took me a very long time to work out, as you can imagine. But by defining this here, I can then control how this is pronounced with Azure's speech services. So if we look up here, I think I've chosen, a US English person, and I'm able to say how I want them to pronounce things. I've not chosen any lexicon, and I think I can just hit play somewhere. Top left, thank you.
Umbraco.
That's a bit loud. umbraco. So that's probably how an American would actually say umbraco. But that's not how I would like to. So down here, we have our lexicon file that's been loaded in. It's failed to find a voice. So I need to select a UK voice because it's a UK lexicon file, and I'll go with Ryan. Yeah, cool. And then I can choose my ENGB lexicon here. So just to show you the difference, I'll do it without the lexicon file first. Oh, can I? I don't know. Doesn't really matter. We'll play them both. Come on.
Umbraco.
So umbraco versus umbraco. Just subtle difference, but it's using that lexicon file to tweak the model and tweak the output and control how the model is generating the audio. So just because you can't get the model perfect, and maybe your training data wasn't perfect, maybe someone even said something wrong when they were training the model, you can still change that later. And Azure Custom Neural Voice will do a pretty good job of then adjusting, following those principles of speech and sound that we mentioned earlier to make this work. Whilst we're in here, we can also have a bit of fun with the speaking styles. It's only available for, say, the US language that do things like whispering, which is really annoying, but it's quite fun. So I'll change this. I'll go, hey, it's lunch. No, it's beer, isn't it? It's beer time. Hey, it's beer time. Cool. So I need to select the voice for that. I've got to select a English United States voice. We'll say Ava. And these are just banks of the pre-approved voices that are, there's like 1,500 voices or something that Microsoft have got available to you there. If I had deployed my trained voice, my neural voice, I could select that here too, but I've not done that for a reason we'll go into in a second. So you can control things like the speed that it's spoken at. You can control the pitch, the volume, but you can also, not all of the voices, annoyingly, not all of the voices have all of these attributes as well. So Guy has a speaking style. We can say, make him sound excited.
Hey, it's beer time.
Hey, it's beer time. And then why not? Let's just make him whisper that as well for fun.
Hey, it's beer time.
I wouldn't have said that was a whisper, but whatever. Some of them do it better than others. If you trained your model on the Pro model, you can unlock a lot of these features yourself. I believe it's still only available for ENUS-based models, which is really annoying, but it'll come at some point. Okay, so this was kind of fun. Let's talk about some serious potential, real use cases for this. You could use this in your professional applications. You could use this for your telephone systems. It's quite easy to get up and running. But I think there's some real practical use cases for this technology too. Accessibility for people that are hard of hearing or have speech disorders, for just two examples. This is potentially a way that they can communicate more easily with people who are more able at hearing or speaking. It's fairly easy to get up and running. So actually, there's quite a lot of value in that. For things like translation, this is really powerful. A slight tangent there. In November, Microsoft unveiled a new feature service within the speech collection called personal voice. So you've got neural voice and you've got personal voice. And personal voice is effectively a minute of audio is all it needs, and away it goes, and it can then change you to speak Spanish or whatever else. It's very good, but it's in public preview right now, and I don't know if it's necessarily got the same level of control over things like quality. So you can see that there. But yeah, wouldn't it be great if I could use my voice to speak Spanish without me speaking Spanish. I don't know. Things like security. How many people's banks have a copy of their voice that when you call up, they just check that against a database to make sure that it is you? Yeah, you could roll this out yourself if you wanted. You could create your own virtual assistant, and the Speech Studio actually has a great tool for doing so. Once you've generated a voice, you can generate your own assistant, and yeah, it can speak to you, which is very odd. Or a time capsule. I mean, there's some precious voices we'd like to be able to hold on to forever. David Attenborough, Morgan Freeman, etc. Wouldn't it be nice if we had neural voices for all of these people at some point as well? Or just a loved one, you could even do that for. Okay, FAQs, how much does it cost? I didn't really want to talk about this, it's quite expensive. $52 per compute hour for training, which is not cheap, I admit. That light model that takes around an hour to train means you're paying $52 and a bit more, potentially, to train it. Those pro models that take 24 plus hours to train are going to cost you a lot of money. So, yes, that is USD. Thank you. I forgot dollars. Then, when you deploy, as in make your neural voice usable anywhere in the Azure speech stack, you pay $4 USD an hour to keep that there. So realistically, you only want to deploy it when you need it, and then you can remove it. So if you were going to, do a demo like this today, you might deploy it for that and then remove it. If you were going to use it in real time always, then you have to consider that's part of the cost. You've got to pay $4 an hour to keep it running. Can you use this in your apps? Of course you can. There's a whole bunch of SDKs for this, for C#, for C++, Python, Go, Java, Objective-C, JavaScript, the lot. So you can use this kind of anywhere you want. Do you have to create these custom voices? No, you don't. If you just want to use their text-to-speech services, you're more than welcome to, and they've got 400 plus voices available with all of that control over things like whispering and all this sort of fun stuff. No, so with that, you don't have to pay for the training cost, and you don't have to pay for the deployment cost either, because they're just part of the service. Not to mention, $4 to pay for it to be deployed, but then you've got to pay to use the other services that you want to use it with. So it just gets very expensive. I burned through so many Azure credits in preparing this. There's also a whole bunch of other open source text-to-speech, speech-to-text libraries that you should check out. And I think this list is huge. These are just maybe the three biggest ones. I'd love to know if people have experience with others. But Whisper from OpenAI, which you can now deploy directly in the Speech Studio because Azure has their OpenAI service. You can run Whisper on Azure OpenAI service with a couple of clicks. So you can do this directly yourself, but you could also host it locally if you wished. Deep Speech, which is from Mozilla, and Mimic, which is from a company called Mycroft, are all really good tools as well. So potentially have a look at those if you're interested. And with that was my whistle-stop tour over custom neural voice in Azure. I hope it's maybe inspired you, enlightened you to the world of cloning yourself. Of course, I'm on GitHub. I'm still on that Tweetybird app. LinkedIn as well, same username everywhere. Thank you very much.
Take that down to charging you $4 an hour. It's easy to click deploy.
It takes a couple of minutes to deploy. Yeah. No, you don't. The training's happened, but it's just a pain. It's expensive. I guess it is. I guess it's primed for use. But then I don't know how that would apply to the various different services you can use it with, because they surely run on completely different compute. So I've no idea what it's doing. Yeah, I'm guessing that is it, but I'm hoping probably with, say, OpenAI service and stuff as well, the more AI workloads people are running, the cheaper this becomes for them, and these costs come down. But yeah. Oh yeah, thanks everybody coming to the last talk.